Hi everyone, this is E.M.P, Electromagnetic Precursors for Earthquakes. So here's the last TEC map we were using in the previous video. And remember, TEC is basically ionospheric electron density. We view that as ionospheric capacitance. First thing I wanted to look at is this huge area of capacitance here and the streak going across Africa all the way to South America. Almost looks like lightning right here. If you know your plasma physics, when you have electrical current that flows through plasma, it tends to form into helical structures just like so. So we really couldn't ask for a more powerful electromagnetic precursor. It's definitely what we're seeing here. We'll come back to that in a moment, but I just wanted to start over here first, over Nicaragua. When we jump to the 14th of June, you can see in the same area, huge black blotch with the blue around it, so we're seeing extremely elevated capacitance right off the chart in basically the same area. So you see this, you really want to watch that area carefully because it's definitely prone to charging of the ground beneath it, and that's where you tend to get earthquakes. Looking at P1X Canada's neutron monitor at about 0200 universal time, a couple spikes there. Remember, neutron density spikes are discharges of the capacitor. The capacitor model is analogous to plasma lamp. The outer glass sphere here would be the ionosphere, which is one plate of the capacitor, and the interior sphere here inside would be the ground of the Earth, and in between would be the dielectric insulator, and the discharges are the apparent neutron density spikes. We did have a magnitude 4.9 earthquake near the coast of Nicaragua at 3:45 universal time. And looking at Ottawa's magnetometer, you can see at about 0200 universal time, definitely a big uptick in magnetic activity right there just before we had the earthquake at 3:45. And back that up further, looking at Port Stanley, way down south off the coast of South America, you can see definitely had an uptick in magnetic activity there as well. So two magnetometers to back up each other for a ground-based observation of magnetic activity. Second earthquake we wanted to look at was magnitude 6.2, Vanuatu, 13:49 universal time. So it's just over here, basically right smack dab in the middle of that black blotch and the red-orange blotch in the ionosphere. So you're seeing that in the same area. Again, you want to watch it very carefully because it's extremely volatile. Now, looking at Spain's neutron monitor, you can see at about 1300 universal time, so just about an hour before we had that earthquake in Vanuatu. And Ascension Islands magnetometer, you can see that magnetic activity just hit the ceiling there. Then Africa's magnetometer, you can see the same thing at 1300. Magnetic activity just fly sky high. So there's two magnetometers again backing up the discharging of the capacitor or the apparent neutron density spikes. And then magnitude 5.6 southeast of Ryukyu Islands at 15:01 universal time. So going back to the ionosphere, so it's just over here, which is definitely still in the proximity of this huge ionospheric capacitance. And it's looking at gamma rays. You can see at about 1400 universal time, gamma rays started spiking again. And Japan's magnetometer, you can see that basically since the beginning of the day, magnetic activity has been going up, up, up till we had the earthquake at about 1500 universal time. Same thing on Russia's magnetometer. Last earthquake I wanted to show you, magnitude 4.9, southern mid-Atlantic ridge, 2242 universal time. So back to Spain's neutron monitor, let's see where that spike was at 1300, and then another one here at about 2200 universal time. And back to Russia's magnetometer, and see that after 1300, we had the second spike at about 2200, and magnetic activity is definitely spiking there. Oh, one last thing I wanted to show you was that my gamma rays started going off just after 1200 universal time. There's a spike in E.M.P, the interplanetary magnetic field activity, and just before 2200 universal time, another spike there. So it looks like that was definitely playing a role again for electromagnetic precursors for earthquakes. And that's all I wanted to show you for now. Take care. Thanks for watching.